Hey everybody, it's Mr. Stoneberg. Just wanted to make a quick video here over this. So a couple of these questions on this worksheet. I'd say probably 90 to 95% of y'all are turning this in with the same issues, and I've returned it to some, and some are still not quite understanding what I'm talking about. So we're gonna just go through these two questions, make sure we're on the same page. So let's talk about these two examples down here in this table. This solution 3 and solution 4 here, giving everybody some trouble. So let's look at example 3 first. So solution contains 20 grams of KClO3. So potassium chlorate. It's at 50 degrees Celsius. But here's the big kicker. It's 50 milliliters of water. So our solution, the volume of the solution that we're talking about is only 50 milliliters. So most of y'all are just coming up here and checking the solubility of KClO3 at 50 degrees and seeing that it's 20 grams. Well, what you have to remember is that this graph is grams per 100 grams of water, or 100 milliliters. So everything, all the information on this graph is accurate, but that's at per 100 milliliters of water, which is fine. I mean, it's just a ratio. It's grams per something. So if you know what that ratio is, you can apply that to other volumes. In this case, our other volume is 50 milliliters. So all you math wizards out there could probably figure out that 50 milliliters is half of 100. So if you have half the volume of what the graph is talking about, then what should happen to your solubility? It should go in half as well. So if you only have 50 milliliters based on this graphical information, it's 20 grams per 100. So what would be the saturation point at 50 milliliters? It's not 20, it's half. It would be 10. So at this temperature, at 50 degrees Celsius, and potassium chlorate and 50 milliliters of water, you should only be able to hold 10. So this line should actually be down here. So go back to our example, and it says we have 20 grams at this temperature and this volume. So that would put our data point at 20. Remember, our line should be down here. So the data point is above the line. That makes this super saturated. I know that's not one of the options, but you should be able to figure that out. It's super. I'm really good at this. This is probably one of my favorite things to do right here. Super. All right. So let's look at solution 4 here. 70 grams of potassium iodide at 0 degrees Celsius. So 70 grams of potassium iodide at 0 degrees Celsius. But what's happening to our volume this time? This time our volume is 200 milliliters. So what did we do to it? Essentially, it's doubled what this says, right? So if it's double what this is, then that means that solubility is doubled. So at 0 degrees Celsius, potassium iodide solubility is 130 grams, but that's per 100 milliliters of water. We have 200 milliliters of water. So guess what we can do with that 130 grams? We can double it. 130 grams times 2 would be 260. So this would be unsaturated. Can I type in here? Maybe not. I'm trying to. Just kidding. Let's go back to this. Unsaturated. Yeah. All right. Well, how unsaturated? That's the question. So we said double it. So 130 times 2 would be 260. So 260, yikes, is our capacity. We have 70 in there. So 260 minus 70. That tells you how much more you could add. Okay, I hope this helped clear it up a little bit. I'm sorry if there was some confusion. I know these things can be difficult when I'm not there to directly ask questions, but very few of y'all are asking questions directly. Don't be afraid to contact me through the chat function or email or just any way through Teams. It's I have the app on my phone, so anytime you post or put a message on there, I get notified. So even if it looks like I'm not online, I can still get your messages. So keep that in mind. All right, talk to y'all soon.